Hello, I'm David Kaplan, and this is In Theory. What do we know about the Earth? Well, surprisingly little. We do know that the continents drift. There are plate tectonics that cause features on the surface, but we don't know exactly why that occurs, and we don't know why it doesn't occur on other planets. The way scientists are going to learn about the process that created the Earth is by getting evidence for the entire solar system. How was the sun and the other planets created as well? So here's what we know and how we know it. At the beginning, we believe the solar system started as a gas cloud that moved around the galaxy. And at some point, a star nearby exploded that sent a shockwave through it. That ripple caused the gas to gravitationally collapse, forming the sun and a protoplanetary disk around it. During the first 100,000 years of this solar system, the dust is colliding into each other and creating little clumps. This is called the primary accretion stage. And by the end of the 100,000 years, a kilometer-sized rock is enough to accrete or gather additional material and allow it to grow. That continues on for roughly 10 million years. The inner part of the solar system has rocky planetesimals becoming planet embryos, whereas the outer planets are becoming much bigger. It's colder out there, and so when the dust and clumps hit each other, they attach more easily. And so things are more efficient and grow bigger. The next 100 million years is the giant impact stage. That's when much larger objects are colliding with each other. The planetesimals are really forming and becoming the planets that we know and love. With roughly 4 rocky planets in the interior, 2 gas giants, Jupiter and Saturn, and 2 ice giants, Uranus and Neptune. Right in the middle of there's at 60 million years, we believe the moon was formed. And the current theory is that an object the size of Mars crashes into the Earth, knocks some debris off of it, and a very hot molten goop stays in orbit around the Earth. That goop cools into a spherical object and becomes the moon. So part of that impact stage was also the creation of the Earth-Moon system. For the next 600 million years, we go through a late accretion stage, where you have Pluto-like objects crashing into the Earth and to the other planets, and depositing metal. You see, metal, which is a very heavy element, sinks towards the center. But in a late accretion stage, if something hits the Earth, metal can be deposited at the surface. And so the trace elements of different metals that we discover today are because of that stage. There's some speculation that a lot of violence occurred between 600 and 800 million years, that Jupiter and Saturn migrated their way towards the inner planets, cleared out a lot more of the rocks and other stuff, and then eventually migrated back out. During that stage, other interesting things could have hit the Earth, like comets carrying water, maybe explaining the existence of water on Earth. At roughly 1.6 billion years, all that heat in the core is trying to escape the Earth, and the additional radioactive elements are heating it even more. That heat plays 2 important roles. It allows activity in the core, like spinning and the molten metal, to remain there, and it is probably the source of the strong magnetic fields on the Earth. It's also important because as the heat tried to escape, it broke up the continents, it broke up the surface of the Earth and created the tectonic plates. Those plates then began to move due to the heat and created all kinds of interesting things and motion of the continents themselves. Much later, other things formed at the crust. All that heat coming out maybe created these mantle plumes, which add additional volcanoes, create hotspots like Yellowstone National Park. We don't have exact dates for all of that activity, but that's a sort of rough picture that we think is going on. All of those things, the tectonic plates, the magnetic fields, the moon, they just turn out to be incredibly important things for life on Earth. They make Earth a very nice place for organic material like us. We don't know why, but as we try to figure it out, we learn what are the properties necessary to create an Earth-like planet. And that's very important as we're searching for other planets within the galaxy. But it's also part of our story. It's part of the story of what created us. And so this period, which is messy and complicated, is worth understanding because it tells the entire picture of how we came to be. I'm David Kaplan, and this has been In Theory.